Morning, my name is Denise and my metrics number is 23DBT 2005, and I will be presenting on the introduction, methodology and the results of our journal critique. So if you can see, this is the journal that we've chosen for our presentation. We loosely based our final project on this journal. A crucial property of fibrous packaging paper for food is water resistance, while strength properties are also very important. To improve these properties, several biocoating solutions were applied as coatings on the paper made of the pineapple leaf pulp. The results suggest that beeswax chitosan solution as the best alternative tested for coating paper to make biodegradable plates. So on the introduction, nowadays plastic food packaging is considered a source of environmental problem waste because it takes a very long time to decompose. And to address this problem, biomaterials have received much attention due to short decomposing times and renewable character. From this perspective, cellulosic fibers are preferred over plastics in food packaging. This current study is concerned with producing fibrous paper from pineapple leaves and effects of the alternative biocoating solution, which are beeswax chitosan, shellac, alignate, gallon gum, and beeswax chitosan. The influences on physical and mechanical properties and biodegradation of the coating pineapple leaf pulp base paper was also investigated to select the best coating that could benefit making this biodegradable plate. So on the methodology, there was raw material preparation, making paper from the fibrous pulp, and the preparation of the biocoating solution and paper surface coating. So there are 5 biocoating solutions that were used, which were beeswax chitosan, shellac, alignate, gallon gum solution, and beeswax chitosan emulsion. So the paper physical and mechanical property testing coating that were tested was the thickness and grammage, the absorbency, the water absorptiveness, the tensile strength, burst strength, and internal tear resistance of the paper. The method used was the Elmendorf type method, and then the surface morphology analysis by scanning electron microscopy was used. The determination of the biodegradation, the production of the biodegradable plates, and the statistical analysis was observed. So on the results, there were 4 parameters, and the first parameter will be the pulping process, and the observation was a fine structure and no residues of the pineapple leaves. And then next would be the grammage and the thickness, and on the observation it was stable and strong. And on the third parameter, it was the tensile strength and barrier, and the observation was it had the highest tensile strength. And lastly was regarding the water resistance, the beeswax chitosan solution gave an improved water resistance. So if you can see at this table, it is the characteristics of paper made from pineapple leaf pulp cooked for various times. So the boiling time was recorded, and the characteristics of the paper from pineapple leaf pulp was also observed. So the boiling time, which took 120 minutes, gave the characteristic that was the texture of the paper was very coarse and it had many residues of the pineapple leaves. The following boiling time that was recorded was 150 minutes, which the texture of the paper was medium and it had some residue of pineapple leaves. And at 180 minutes, the texture of the paper was very fine and there was no residues of the pineapple leaves. Next table would be the grammage, thickness, and characteristics of the paper samples from the pineapple leaf pulp. So what was recorded was the wet weight of the pineapple pulp, the grammage of the paper, the thickness of the paper, and the characteristics of the paper after forming testing. So if you can see, the first would be 200 grams, and you can have a look at the characteristic of the paper after the forming testing. And then the next would be 250 grams, and the following one would be 300 grams. And next table would be the average grammage, thickness, and density of biocoated paper made of the pineapple leaf pulp. So the stuff that was recorded was the type of paper, the type of biocoating, the grammage, the thickness, and the density. So you can see in this table, they have written on the pineapple fiber with the uncoating with the biocoating solution, and this was the coating paper before compression and the coating paper after decompression. And these are just all the results that were observed and recorded. Thank you.
Assalamualaikum. My name is Arif Azahad bin Ashari. My metric number is 23 DBT 18F2031. I am one of the members of group number 1. First, I want to talk about the discussion in this study. It tells how the degradation of the paper plate made from pineapple pulp was studied. The paper plate was investigated for 60 days, and the degradation of the paper plate was characterized by the average weight loss of plate after being buried for every 15 days. They say there was a difference in bio-coated paper with beeswax chitosan. Paper coated after hot pressing with beeswax chitosan solution degraded faster than before hot pressing. It is because after compression, the biocoating solution coated only on the paper surface, but when coated before hot pressing, the solution was heated and compressed into the bulk paper and inducing cross-linking that gave resistance to microbial digestion and degradation. Then they used the scanning electron microscopy (SEM) to study the surface morphology of the uncoated and coated paper. The biocoating field force between the cellulose fiber, leading to high tensile strength and increase the resistance of water. Finally, in production of biodegradable plate, the paper was coated with 1% of chitosan, 4% of glycerol, and 30% of beeswax before compression to form biodegradable plate.
Hi, Assalamualaikum. My name is Nurul Juliana and my measure number is 2015. Today I want to continue presentation. The conclusion of the journal is it was found that paper made of pineapple leaf pulp when coated with a biocoating had improved physical and mechanical properties. This was attributed to bonding due to improved tensile, stretch, burns, and tear resistance, as well as the water absorbency was higher than of paper made of pineapple leaf pulp without coating. The result overall demonstrated that pineapple leaf pulp can be used in biodegradable packaging to reduce the use of plastic.
Next is what good about biodegradable plates. Number one is the food service industry produce more disposable plastic tableware or plate than any other industry on earth. And this is very conscious about the damage that disposable plastic packaging and tableware is causing to the local environment. Using biodegradable plates maybe can reduce the trash that ends up in landfills and the oceans, and biodegradable plate product can remove the negative impact on the environment. Number two is biodegradable plates are environmentally friendly entertaining. Plates from biodegradable material are more environmentally friendly because these do not leave behind toxic chemicals or residue and product degrade over time, releasing earth-friendly nutrients back into the soil. Um, Number three is easy composting. The advantage of biodegradable plates to the environment is that they take short time to decompose and easier to recycle. It is also broken down by natural bacteria that will benefit the environment. Number 4 is non-toxic. Pineapple peel is all natural, non-toxic, lightweight, durable, and natural, antimicrobial, plant-based, and beeswax alternatives are biodegradable, making them eco-friendly. Next is what good from method. Number 1, they use a pineapple peel, which is a high content of cellulosic. Number 2, they use sodium alginate and galen gum. It is to improve the water resistance. Number 3 is beeswax because it high hydrophobicity. Okay. What's bad? From this journal, it did not talk about how much the impact of pineapple peel towards the environment and why the pineapple leaf pulp should be used. It did not state if there is waste management involved as to why this experiment has been executed. Pineapple peel pulp is usually thrown aside after the core is extracted.
Ways to improve in this journal is: first, add methodology measure, plate, peel, stretch and branched structure. Second, add objective for produce biodegradable plate. Third, add objective for evaluation parameters. And last but not least, to use ASTM measuring standard.
Salam sejahtera, Miss and my fellow group members. Today, my name is Vanishri with my matrix number 23 DBT 18F2001, and I'm here to talk about our journal critique and what's interesting about this particular journal. Well, first off, as you can see in this study, a very interesting thing, especially the beeswax cytosine, which was used as a layer to protect the pineapple peel plate, is being used because it has a high hydrophobicity and high content of cellulosic to improve the water resistance. Next off, it also shows that the plant-based natural materials have the strength and can produce biodegradable plate compared to the petroleum-based plastic PET. So in this, we have proof that we can create such a plate. It will take some trials, but it can be done. Next, the biodegradable plates are manufactured using eco-friendly sustainable practices, which means there are no toxins involved in the process of making this. So this is better for the environment, since after we use a biodegradable plate which is manufactured by other companies or by all these factories, when we just throw them aside, we don't realize what happens to it. Sometimes the ones that they create in the factory have toxic layers and things, and it has properties that cannot actually biodegrade. So in this journal, they tried to create something, a pineapple peel plate, trying to use no toxins, nothing which can harm the environment, which in my opinion, I think is really well done, and we should encourage the factory people or the big manufacturing companies to actually create such a biodegradable plate, because now everybody's been thinking about money and nobody's actually been thinking about how important and how risky it is actually to create such a plate, and how important it is to create a more sustainable plate, better for our future. Okay, so what is it we intend from this journal and what will we apply in our FYP? So we're actually quite interested in the methodology. It seems that the methods used to test the biodegradable plate, we would like to extract that and use it onto our FYP. We will change it somehow to suit with what we have in our lab, which means we will try to use the ASTM the American standard of testing for materials, that method, instead of the directly how they have tested on the journal, how they've used, it's just a direct method. We are going to use the ASTM method. Also, we have choose this journal as a reference of how biodegradability can be tested. So from this journal, we know how the procedure is, the flow, starting from the introduction to the methodology to the results and to the conclusion and everything in between. We know how it has been done with such a flow. So we intend to take that as well. So we want to see the flow and see if we can try to make our FYP, our proposal, the same flow as that, so that we don't miss out on anything important while we are doing this experiment. So what we've noticed is that this journal doesn't really talk about waste management. So for our proposal and our FYP, we intend to talk about that. So the pineapple, see, they're using the pineapple peel. So what we are going to do is we are going to talk about how the pineapple peel is just thrown like that, not being considered to be used as anything else, because the main thing we need is the core, which is the fruit inside. Nobody thinks about the peel. So when we decide to use a pineapple peel to make this plate, we also think about the management of the waste management, so we can help to prevent a bun load of pineapple peel everywhere. We can use that. So we talk about, it's almost like reuse, reduce, recycle. So we are using a product which can naturally biodegrade and also is very good for the environment. Thank you.